Impact of food toxins on autism spectrum disorders, ASD. Autism spectrum disorders, ASD, are complex neurodevelopmental conditions characterized by difficulties in social interaction, communication, and repetitive behaviors. The prevalence of ASD has been rising globally, prompting extensive research into its potential causes. Increasing evidence suggests that prenatal exposure to food toxins, particularly heavy metals and pesticides, may play a significant role in the development of ASD. Understanding these associations is crucial for developing preventive strategies and improving public health. Prenatal exposure to toxins and ASD. The prenatal period is critical for brain development, and exposure to environmental toxins during this time can significantly affect the developing fetus. The placenta, once thought to protect the fetus from toxins, allows many harmful substances to pass through. This exposure can disrupt normal brain and nervous system development, potentially leading to neurodevelopmental disorders such as ASD. Associations with heavy metals. Heavy metals like lead, mercury, and cadmium are widespread environmental pollutants that can contaminate food and water supplies. These metals are neurotoxic and can interfere with brain development and function. Prenatal exposure to heavy metals has been linked to an increased risk of ASD. Lead is a well-known neurotoxin that can cause cognitive deficits and behavioral problems. Studies have shown that elevated blood lead levels during pregnancy are associated with a higher risk of ASD in children. Lead exposure can disrupt synapse formation and plasticity, crucial processes in brain development, leading to the characteristic symptoms of ASD. Mercury, particularly methylmercury found in contaminated fish, is another significant concern. Mercury can cross the placental barrier and accumulate in the fetal brain, where it interferes with cell division and migration. Research has demonstrated a correlation between higher maternal mercury levels and an increased risk of ASD in offspring. Reducing maternal consumption of high mercury fish during pregnancy is essential to mitigate this risk. Cadmium, often found in contaminated food and tobacco smoke, has also been implicated in neurodevelopmental disorders. Prenatal cadmium exposure can disrupt neurotransmitter systems and impair cognitive function, potentially contributing to the development of ASD. Associations with pesticides. Pesticides used in agriculture can leave residues on food that pose health risks. Prenatal exposure to certain pesticides has been linked to an increased risk of ASD. Organophosphates, a common class of pesticides, are particularly concerning due to their neurotoxic effects. Organophosphates inhibit acetylcholinesterase, an enzyme essential for nerve function, leading to the accumulation of acetylcholine and continuous nerve impulses. Prenatal exposure to organophosphates has been associated with altered brain structure and function, contributing to the development of ASD. Epidemiological studies have found that children born to mothers living near agricultural areas with high pesticide use have a higher incidence of ASD. Other pesticides, such as pyrethroids and carbamates, have also been linked to neurodevelopmental issues. These chemicals can interfere with neurotransmitter systems and neurogenesis, critical processes for normal brain development. Reducing pesticide exposure through dietary choices and advocating for safer agricultural practices can help mitigate these risks. Mitigating the impact of food toxins. Reducing the impact of food toxins on the risk of ASD requires a multifaceted approach. Regulatory agencies should enforce stringent limits on environmental contaminants and monitor food and water supplies to ensure safety. Promoting organic farming practices and reducing the use of harmful pesticides can significantly decrease exposure. Pregnant women can take proactive steps to protect their health and that of their unborn child. Choosing organic produce, avoiding high mercury fish, and ensuring clean drinking water are crucial measures. Public education campaigns can raise awareness about the risks associated with food toxins and the importance of minimizing exposure during pregnancy. Conclusion: prenatal exposure to food toxins, particularly heavy metals and pesticides, has been increasingly associated with the development of autism spectrum disorders. Understanding these risks and taking preventive measures can help protect the developing brain and reduce the incidence of ASD. By addressing environmental pollutants and promoting safer practices, we can improve health outcomes for future generations.